Today we shall see how a neural network learns. We shall study the backpropagation algorithm in particular. So, artificial neural network has been inspired by the biological neural network, or an artificial neural network tries to mimic the human brain. As you know, the human brain consists of dendrites, axon, synapses, and the same concept has been adopted to develop an artificial neural network. Such a network consists of basic computing units called neurons. So each neuron has a set of inputs. Then we compute the weighted sum of these inputs, and we apply some activation function to limit this output to get the final output of the neuron. Okay. Now, these neurons are interconnected or are organized into layers. We have the input layer of neurons, an output layer, as well as one or more hidden layers for a multi-layer neural network. And a backpropagation neural network happens to be a multi-layer neural network. Let us see how a neural network learns. A backpropagation neural network is a supervised learning method, or the desired output or the target output is known to us. This backpropagation neural network involves backward propagation of errors. That is, we compute the error, that is a difference between the target value and the computed value, and this error is propagated back in the backward direction through each hidden layer down to the first layer. Hence the name backpropagation. Okay. So we begin by initializing all the weights, that is W1j, W2j, and so on. And these weights are also called the synapses. For each layer, we have to initialize the weights. Usually, we initialize it with random values. Then we compute the output at each layer. Finally, we compute the output at the output layer or the final layer. Now, we check whether the obtained output is same as that of the desired or target output. If there is any difference, that is taken or that is considered as an error. That is, we calculate the error as the difference of the predicted and the desired values. Okay. Now, here we are trying to minimize the error. So, a portion of this error is fed back or is backpropagated to the previous layer and to the next previous layer, and so on. And during each step, the corresponding weights are updated. Okay. And backpropagation uses the concept of gradient descent. That is, in gradient descent method, we try to minimize the error. That is, we minimize the error so that it reaches a global minimum. Okay. Now, let us have a look at the algorithm, backpropagation algorithm. So, as input, we are given the training samples along with the target value, and let that be represented by D. Then we have L. L is the learning rate. Now L has to be decided appropriately because learning rate will help to avoid getting stuck at the local minimum during training. If the learning rate is too small, then learning will occur at a very slow pace. And if the learning rate is too large, then there may be oscillations between the solutions. So we got to aptly choose a value of L. Then we begin by initializing the weights, and also there is a factor called bias which is added to the weighted sum of inputs. Okay. Then usually we have a terminating condition. We'll see that later. Now until the terminating condition is not satisfied, what we do is we compute the output at the first layer. That is, output of the input layer is same as the input, or OJ is equal to IJ. Now for each of the coming hidden layers, we have to compute the weighted sum of inputs plus a small bias. So here theta j is the bias, and sigma wij oi is a weighted sum of inputs. Then OJ is computed as the computed by applying an activation function. Here they have used a sigmoidal function. It is also called the squashing function, which is given by 1 by 1 plus e raised to minus 1. Then once we get the final output, we have to backpropagate the errors and update the values of parameters or the weights based on the error. We repeat this until the error is minimized. So how do we backpropagate the errors? For that, we first compute the error at the output layer, or error j is computed as OJ into 1 minus OJ tj minus OJ. That is, we compute the difference between the target and the obtained values of output and multiply these together to get the error at the output layer. Now for each of the hidden layers, each of the previous hidden layers, from the last hidden layer to the first hidden layer, we have to compute the error using the next equation. ERRJ is computed as OJ 1 minus OJ sigma over K error K WJK. Okay. Now, based on this error, we shall update the weights or update the parameters. That is, the new value or the change in weight is computed as delta Wij is learning rate L into the computed error ERRJ and OI. And this is added to the existing value of weight, or the weight is updated using this change in weight. Okay. Wij, new value of weight, is equal to previous value of weight Wij plus change in weight delta Wij. Now for each bias, we again need to update the value in a similar manner. This is repeated until the error gets minimized or the network learns.